Batteries!
Welcome to the world of electronic devices. Let me ask you a question. How do electronic devices work? Well, that's simple. With batteries, of course. So then in that case, let me ask you another question. How do batteries work? Different story, isn't it? Here we see that a battery is hard, metallic, somewhat lustrous, and a good conductor of electricity. So then, how is it that when placed behind an electronic device, the electronic device turns on? Well, with understanding of electrochemistry, these problems can be solved.
And we can all conclude that electrochemistry is the branch of chemistry that deals with the reactions between chemical and electrical phenomena. And I'm sure one of you, at least one of you, have thought of how a battery actually works. Okay, first let's start off with what E0 cell actually is. E0 cell measures the voltage of the cell at standard conditions and is known as the electromotive force. This electromotive force measures the electric current flowing through the cell, and it shows how much current is charging through the system in a electrolytic cell specifically. And we can measure this voltage by using a voltmeter. But if we do not have a voltmeter, we can use our reduction potential part that you are given on the AP exam. And then we can then use that to figure out what is being reduced and what is being oxidized, and from that you figure out what is at the cathode and what is at the anode. The cathode will have a higher reduction potential, while the anode will have a lower reduction potential. Here we have an example of cadmium and tin, two half reactions. To find the EMF of this reaction, we must go to our reduction potential. As you see here, the reduction potential for cadmium is negative 0.403, and the reduction potential for tin is negative 0.136 volts. We then do the cathode minus anode equation and plug in the numbers to get 0.267 volts, and that is your EMF. Now, on the AP exam, they will ask you what delta G is, and will ask you to calculate the value of delta G using electrochemistry. Delta G gives free energy, and can be found by using this equation right here. Delta G equals negative NFE. N is the number of moles, F is Faraday, which is a constant. (96,500 coulombs), and E is the electromotive force, EMF, or E0 cell. Now, not every time will it be under standard conditions, so when it's not under standard conditions, you use this equation right here. This is the easier one. E0 cell minus 0.0592 over N times the log of the reaction quotient. One last thing I would like to let you know about electrochemistry is a process called electrolysis. Electrolysis reactions occur only in electrolytic cells, remember that. They can be used for electroplating and in metallurgical processes, but for now you don't have to know what that means. Products of electrolysis reactions can be determined by using the reduction potential chart as well. Here we have a voltaic cell. It's specifically an electrolytic cell. But what is that? So, an electrolytic cell is made up with two half cells, and in each half cell there is a half reaction going on. In the cathode, there is reduction, and in the anode, there is oxidation. So remember that there is a saying that Ms. Parker taught us called red cat and ox, reduction at the cathode, oxidation at the anode. A reduction reaction occurs in the cathode, and an oxidation reaction occurs in the anode. First, we start at the anode. The electrons are lost in the anode, and then goes through the wire, through the load, and into the cathode. At the cathode, electrons are gained, and from there, the anions that are produced go back through the salt bridge and into the cathode, where the cycle starts all over again. In the cathode, electrons are gained. Remember this, always remember this. There, the anions produced in the cathode half reaction then go back through the salt bridge to start the process all over again and again and again until there are no more electrons left to give, which is when the battery dies and you have to go get a new one.
So as you can see, simplistically, this is how a battery works. Now, hopefully you have a better understanding of electrochemistry, and it'll help you down the road when you take on and tackle these hard, vicious problems that you're going to encounter in the next few lessons that you learn. And now that concludes this video on electrochemistry.
Good luck.